Hello, in this video I am going to talk about the spanning tree. What is spanning tree, what are their properties, as well as we are going to see what are the applications of the spanning tree. Let's begin with the definition of the spanning tree. Spanning tree is a special kind of subgraph. It includes all vertices of the original graph. It stays connected and it do not have a cycle. If you observe this figure, this is our graph and these three are the possible spanning trees of the given graph. If you observe that each and every spanning tree is a connected, it do not contain the cycle as well as it has all vertices which are present into your graph. So in simple words, I will say that spanning tree connects the all vertices together with the minimum number of edges. So if you think of cities connected by the roads, a spanning tree is the simplest way to connect all the cities without forming any loops. Remember, spanning tree is only possible for the connected and undirected graph. Let's look at some properties of the spanning tree. First property is related to the number of edges. If graph has n vertices, then every spanning tree of that graph will have exactly n minus 1 edges. If you observe this image, the spanning tree contains the 3 vertices. So number of edges exactly 2 in each spanning tree. Next property is related to the connectivity. Spanning tree is always connected. It means that there is only one path present between the two vertices. Consider this following example. There is only one path possible between 2 and 3. I need to go from 2 to 1. Then after that you can reach to the 3. Same thing will be applicable here. Suppose I just want to check out what is the path between 1 and 2. Here as well only one path is possible. But this is the graph. It's not a spanning tree. So if you observe that the path between 2 and 3, there are the two ways. From here as well I can go directly to the 3. Otherwise 2 to 1 and after that I can reach to the 3. So this is a graph and these are the spanning trees of the given graph. So in the spanning tree, only one path is possible between the any two vertices. Next property is the spanning tree do not contains the cycle. If you observe all this spanning tree, it do not have a cycle. Next property is related to the edge removal and addition. If you remove any edge from the spanning tree, it becomes disconnected. But if you add new edge, it will form exactly one cycle. Consider the following spanning tree which contains the 4 vertices. So number of edges in the spanning tree will be 3. If you add one edge, it will create exactly one cycle. And if you delete any edge from this spanning tree, it will become a disconnected. Next property is multiple spanning trees. A one connected graph can have a more than one spanning tree. If you observe this example, this graph can have a maximum 3 possible spanning trees. Next property is related to the total number of spanning trees. For the complete graph with n vertices, number of possible spanning tree is n raised to the power of n minus 2. Connected graph means each and every vertex is connected to the other vertex. Following is an example of the connected graph with 3 vertices. It means value of n is a 3. So maximum number of spanning trees will be 3 raised to the power of 3 minus 2. It means 3 raised to 1. So number of possible spanning trees are 3. Consider the value of n is a 4. It means the graph contains 4 vertices. Then maximum number of spanning trees will be the 16. Now what are the applications of the spanning tree? First application is a network design. Consider you want to connect the all computers of your office. So in that case, we can use the spanning tree which do not contains loop so that we will get to know that how much minimum cable required to connect all this system. Same thing will be applicable for electrical and communication networks so that through the minimum number of wiring I can able to connect the different devices. Next application is broadcasting in the network. We can send the message to the all devices without repeating it. Next one is a cluster analysis. This is used in the data science and AI. When we remove the longest edge from the spanning tree, it will forms the separate group. Last application is approximation algorithms. The traveling salesman problem is a best example of this. Within that, we are going to find out the shortest route so that salesman can visit the all the vertices. I hope you understand what is a spanning tree, what are the properties of the spanning tree, and what are the applications of the spanning tree. Thank you.